2.4, we're talking about average rate of change. And the average rate of change, we all know, if it's a linear function, meaning if we have, let's say we have this graph, right? And we have this line here. Yeah. That means the average rate of change is your slope. So we're essentially just getting our slope, okay? Which is m, which again is y2 minus y1 over x2 minus x1. Why this book has its own section on average rate of change is because the average rate of change is not just the slope, because we're dealing with functions that look like this. Okay, I'm going to do my best to draw something here that looks like maybe that. Okay, it's not going to be a line like this where it's a constant slope, right? Your slope stays constant throughout the function. Here, this slope is different from this slope is different from this slope, right? Yeah. So everything is a little bit different. So that's why we call it average rate of change. But the formula still holds true. Okay. The only difference is the problem itself is gonna give you what your x values are. Hey, let's get the average, like a example problem would be, what is the average rate of change between x equals 1 and x equals 5? Okay, so you're going to be given these x values, or you're going to have to figure out what the x values are, right? And then we're just going to plug it into this slope formula. Okay, that's the general notes for today. Because today what we're going to do is a lot of word problems. Okay, so before we go over word problems and whatnot, let's do some problems like this. Let me share my screen. And we're gonna do problems like 11 through 24, okay? So if you look at, let's do number 15. Okay, so if you guys see number 15, okay, write down number 15. I'll write it on a sheet of paper and stop my share so that you guys can see it. It says h of t equals 2t squared minus t, where t equals 3 and t equals 6, right? And the directions say a function is given. Determine A, the net change, and B, the average rate of change between the given values of the variable. We're just going to do B. Okay, I just want to focus on average rate of change between the two variables. All right. So we have this as our problem, right? So we have t equals 3 and t equals 6. How do I get the y values if t equals 3? What am I going to do? Plug it in. So h of 3 equals, notice that it's h of t. So I just put t equals 3 into my function. So 3. So 3 minus 3. I'm just going to put that for now and just color coordinate this. 2 times 3 squared minus 3, which equals 2. Remember to do the exponents before anything because it's PEMDAS, right? Please excuse my dear aunt. So I'm Korean. I don't have an Aunt Sally. I'm kidding. Aunt Sally, right? So 3 squared is 9. Okay, so exponents come before multiplication. Minus 3. Multiplication comes before subtraction. So that's 18 minus 3. So that's 15, right? So we have a point on the graph that's 3, 15. Okay. Do the same thing with 6. So 6, h of 6 equals 6. 2 times 6 squared minus 6. So 6 squared is 36. 2 times 36 minus 6. 2 times 36 is 72. Minus 6, 66. So we have a 6, 66. So now we can get the average rate of change, right? So I'm just going to rewrite these 2 points, 3, 15 and 6, 66. I like to label 1, 2. Okay, you don't really have to do that, but then it just keeps me on track. Okay. So remember your slope or your average rate of change equals y2 minus y1 over x2 minus x1. So y2 is 66 minus y1 is 15. Am I going too fast? No. x2 is 6 minus x1 is 3. So do this math really quick. 66 minus 15, 51 over 3. Does 51 go into 3 or does 3 go into 51? If you don't know, do you know the rule? Do you know the rule of divisibility of 3s? If you add 5 plus 1, what is that? 6. Does 6 go into 3? Therefore, this big number goes into 3. Now you know. Knowing is half the power. So if you have a big number like 1, 0, 4, 3, 5, 7 divided by 3, and you don't have a calculator, right? This is the SAT or whatever you guys take, right? The SATs do not want you to do this. Yeah. And just take your time. They want you to do that because they want you to waste your time. Literally. They want you to, this is a time sucker. Yeah. They want you to kind of spend time on this so you don't have any time for the later ones. But if you just add these guys up really quick, 1 plus 0 plus 4, that's 5, 8, 13, right? 20. So if the question was, is this divisible by 3? It's a no. Because 20 does not go into 3, right? Therefore, this big number does not go into 3. Now you know. Okay? So 51 divided by 3 is, 17? So that's your average rate of change. Okay? You guys know the trick between the fingers and the nines? No? Yes and no. So I have 10 fingers, right? 9 times 5. Really quick, that's 45, right? But 1, 2, 3, 4, 5. Put that one down. 45. 4 fingers and 5 fingers. So it's 45. 9 times 7. 1, 2, 3, 4, 5, 6, 7. Put this one down. I have 6, right? And I have 3. So it's 63. Now you know. All right. That's that. Okay. And so now what I want you to do is to turn your books, or should I do? Let's do number 31, and I'll share my screen out again. Okay, 31, it says, you guys can see that as well. So I'll just do the work here, and hopefully on the video, it just comes out like this too. For number 31, it says population. The table gives the population in a small coastal community from the period 1997 to 2006. Okay. Figure shown are from January 1st of each year. So that's the table. Part A, what was the average rate of change of the population between 1998 and 2001? So this table here, it breaks it down for you, right? Yeah, in terms of year to population, correct? What I'm gonna do is I'm gonna label this label the years, my X value, and label the Y's, or label the population as my Y value. So we're essentially doing the same thing, but just in word problem form, okay? So if you think about it like that, years is X and population is Y. And another way you can think about it is if you guys look at this little graph. If I graph this, years and population, would this make sense? Years and population? Or would this make sense? Population and years. Which one would make sense graphically? Population on my y-axis or years on my y-axis? The population, right? Because the population is a function of years, right? As more years go on, the population grows or increases, right? Depending on what happens that year, correct? Not the other way around. Years is not a function of population. Does that make sense? Meaning, if my population grows, does my years grow? No, because time is just, it just goes, right? Yeah. So years is my dependent variable, if you guys can see that on a little screen. Yeah. Whereas population is my, or years is my independent variable, because years just go, right? It doesn't have anything that it depends on. And population is my dependent variable. Okay? So if you think about it like that, that's how I got my X and my Y value here and here. Okay? All right. Now part A, you're already given my X values, right? It's 1998 and it's 2001, right? I'll write it bigger. Yeah, so if I look at my my population, In 1998, it was 856. That is a small community. In 2001, it became 1591. Yeah. So with these 2 points, you guys can just plug it into the slope formula and get that, right? The average rate of change. So let's take about 2 minutes, not even, maybe even less. And let's, all right, let's look at this problem. So I got, I labeled my points 1 and 2. So Y2 is 1591, Y1 is 856 divided by 2001, X2 minus X1, which is 1998. 1591 minus 856. 735 divided by 2001 minus 1998. That's 3. I have no idea if 735 goes into 3, but we just got it over the divisibility rule. 7 plus 3 is 10. 10 plus 5 is 15. 15 does go into 3, so this big number does go into 3. So if you just divide it out, that would be 245. So class, this 245 is not just a number, right? It represents something. What does it represent? The slope, yeah. But what does it represent in terms of this problem? The rate of change of the population. So between 1998 and 2001, each year, the population on average grew at a rate of 245 people. Yeah. And that is the kind of the main idea of this lesson. Okay. Because this number is just not a number. It represents something. And we have to write out what it represents. Therefore, you guys know these 3 dots means therefore. Yeah. Between 1998 and 2001, the population grew at a rate of 245 people per year. All right. And this is what I'm looking for in terms of word problems. Can you guys decipher what that number actually means? Okay. Questions on that? No? Easy? Easy peasy, lemon squeezy? My son always says that. Part B, then you guys can do yourself, right? 2002 to 2004. Same process. Yeah, just get the 2 points, get the slope, decipher what it means. How about for part C? For what period of time was the population increasing? So you start from 1997, right? Oops, sorry about that. Honestly, don't know how to get rid of it. Let's just put it like that. Okay. So from 97, it grew, 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 and then it stopped growing, right? Yeah. So from what time period did was the population increasing? From 1997 to 2001. From what period was the time was the population decreasing? From 2001, drop, 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 right? So from 2001 to 2006, yeah? So it's just deciphering, can you guys read the graph? All right. We are doing this one. I believe it is, let me move this a little bit, 34. Okay. It says between 1980 and 2000, a rare book collection or rare book collector purchased books for his collection at a rate of 40 books per year. Use this information to complete the following table. Note that not every year is given in the table. I would not have given you guys this hint. Yeah. Okay. So you guys have to, so from 1980 to 2000, he collected books at a rate of 40 books per year. Okay. So from 1980 to 1981, that's a growth of 40 books because that's 1 year. Right? What's the next one? What is 1982 then? Huh? 500. Okay. 500. I can't do that. So my next step is 500. Let me see if I can write it with my mouse. Okay. How about from 1982 to 85? Well, that's 3 years, right? 83, 84, 85. 3 years. 3 times 40 is 620. Okay. So that's 620, and then you guys can fill out the rest, right? That will be a homework problem. Okay. All right. We are doing number 36, farms in the USA, United States. The graph gives a number, the number of farms in the United States from 1850 to 2000. Okay. Estimate the average rate of change in the number of farms between between these two years, 1860 to 1890. Okay. 1860 has about 2,000 farms, right? So we have a point of 1860, comma 2000. And we have another point, 1890. Do you look at 1890? Well, 60, 70, 80, 90, yep. Where is it? So this is 1860, 1870, if you guys follow my mouse, 1880, 1890, and 19, right? So this is 1890. You go up to that point, is right there. You go across, that's about 4,000. And then you guys can get the average rate of change, right? So 2 is the same thing. Part B, in which decade did the number of farms experience the greatest average rate of decline? Do you have to look at every single year and get the slope or and get the average rate of change? Are you going to? No. What are we looking for? The steepest decline, right? So it's going down, right? So all of this that's going up, that's not it, right? All of this is not it, right? So let's go with this. This is kind of steep. This is a little steeper. And then there's a big drop from here to here, right? And it kind of levels off, levels off, levels off, levels off, right? So it has to be this guy that goes from hold on. 1950 to 1960, right? Because if I make a line that's 1950, and that has to be 1960, right? So which decade? The 1950s. Okay? Make sense? And we're just analyzing each graph. Okay? Any questions on this so far? So that is 2.4. Okay? That's your 2.4 lesson.